Okay, this is part one of a multi-part tutorial that's based on the Design Reform Parametric Truss tutorial. So this is a variation on this kind of classic grasshopper example. This has been done a number of times by the guys over at Design Reform. I think this latest one's by Dave Fano. And it's a great tutorial. We're gonna extend it a little bit, and we're gonna work on kind of organizing our grasshopper definitions into functions as we go. So this is as much about geometry creation and component aggregation as it is about grasshopper best practices and the ways we can use kind of functional grasshopper logic to really organize our thoughts and hopefully model more effectively. So this is going to be a multi-part tutorial. The first part is going to focus on just creating the subdivided surface that's used to propagate the components. Second part will be drawing triangular faces. You can kind of see those. Those are the outermost faces there. There will be three parts about offsetting and creating fillets within those faces. One method just uses a single driving parameter to offset all of the geometry the same amount. And we're going to look at two additional methods. One that uses the original triangular faces area to compute the offset amount, and a second where we can drive that offset range within a distance to an attractor point on a UV point on the surface, which we'll control with this 2D slider. So let's get started. We'll create a brand new grasshopper file and we'll recreate this function in part one. Okay, so as you can see, I have a single surface in Rhino and three curves. So let's start by referencing those two things in. I'm considering all of these one thing because we're going to loft them and create a surface. So let's start with that. Um, I grabbed a curve component from the Params tab geometry section, and I'm going to set multiple curves. One, two, three curves in the order I want them to be lofted. And I'm going to name those. So as you might have noticed, we have a kind of a color scheme going on here, and the idea is that we can use the groups in Grasshopper to kind of organize our logic a little bit. So we're always going to create or color reference geometry from Rhino as red. The outputs of our functions are going to be orange, and what I call clients of those outputs, components that just pick up data from those outputs, will be yellow. Uh, and as you can see, the functions go from either Rhino inputs or clients from right to left to outputs. We'll also look at visualization and some other kind of grouping techniques here. Okay, so back to it. We have our three curves so far, so let's group those. I just press Control G, and I'm going to double click just to make that round. Now I'll right click the group and give it a name in this little box here. So I always prefix anything I reference in Rhino with RH underscore, I'll call these input curves, or section curves is probably better. And we'll do that one more time for our little surface. So set one surface in this case, and we'll select him. To get the colors, I'll show you how to change colors, but you can always change a color in this little context menu, but there's also this little shortcut to make color default, and we'll use that quite a bit. So again, Control G to group, double click to make a circle, and I'll name this RH underscore single surface. Alright, so let's loft curves to get started here. Go to surface loft from the freeform section. Attach the curves and we get a nice lofted surface. Now, the idea is to subdivide this surface into smaller 4-point surfaces, similar to the first example with the X grid from the last tutorial. And we'll be able to switch back and forth between a single 4-point surface, which we'll use to kind of build our prototypical component, and the set of all of the subdivided surfaces by switching just which output we connect to in this function. That'll become clearer as we go. So first, in the Math tab, Domain section, divide domain squared is what we need. This should be familiar. Our input, our base domain is the lofted surface, and we'll need two sliders. So double click, slider equals 10. We'll initialize an integer slider, and I'm gonna set the upper bound around 25, lower bound around 2, just so we don't get very, very large populations or zero size populations. And I'll just copy and paste that. So that's going to be those are our UV driving parameters. And to actually get the subsurfaces, we'll go into Surface, Utilities, Isotrim. Again, that was the Isotrim tool out of the Utilities section here. The surface we're subdividing is our lofted surface, and it's asking us for domain subset, and those are our divided domains. And there you go. So now I can hide my inputs, and you can see that these sliders are now driving all of these subdivided trimmed pieces of that original surface. Okay, we're getting close here. So the last thing we'll need is a server for this function, is what I always call it. And since we're going to be looking for surfaces downstream, we'll go to params surface, and we'll connect all of those into that. Now this is going to be our server. So I always hide the wires. I'm right-clicking and hidden display, and I'm going to name this, group it. So Control G. I'll change the color to an orange like we saw. This is a little touchy, but you can zero in on one. And I'll name it driving surfaces dash server. Now I always immediately copy and paste that, and I'll change the color to a yellow. And this will be my client. So I just delete the word server here and connect the output from the server to the input of the client. Okay, this will all become clear why we're going through all this fuss as we go. Lastly, I'll just hide everything that I don't need to see. Spacebar brings up that nice little context menu. And we'll give this function a name. So from the special section of the params tab, there's a scribble component where you can make a quick note. And we'll call this create driving surfaces. We'll make this text nice and big. So the idea here is that we can kind of zoom out of the definition and still be able to get a sense of what's going on at each part of it. I'm going to wrap all of this up in one last group and make the color a very light white that's pretty transparent. Okay, so there we go. Now we've got our nice little function, and the output is, in this case, a list of 100 surfaces, and we can control how many surfaces we want to provide in that list with these sliders. And in the next step, we're going to use just this single surface, and I can quickly overwrite it to pass only that one surface into the server and then to the client. So we'll use this one little surface as the way to kind of design our component, and as we go we'll be able to very quickly test the whole population of surfaces and the single one. Okay, that's it for part one. We'll be back with part two in just a bit.